Fisher inverse hyperbolic tangent and the 0.5 logarithm, the logarithm will give out the same values over values of x between -1 and 1. We will also generate the Taylor-Maclaurin series sum of ATANH, the inverse hyperbolic tangent, which is equal to the summation of a times x to the power 2n plus 1, where a is 1 over 2n, and the values of n will start from 0 to infinity. But in this case, we don't have space, so we're limited only to the dataset range. So that's 0 to 8. So let's generate the dataset of the Fisher using array formula. Fisher of the x values. Our x values is between -1 and 1. We can it will give you the same output using inverse hyperbolic tangent array formula. A tan h, that's inverse hyperbolic tangent of the x values. They have the same values formula. And as well as our polynomial regression to the degree 8, they're on the same line because they have the same uh, coefficients. This is b1, they have a match on b1, and this is b0, b1, b2, this is actually 0, b3, this is 3.32, they are the same, b4, they have a difference, but this is very small, 7.47 times 10 to the minus 15, 1.38 times 10 to the, this is 0. So, and b5, -9.44, they match, b6, 0, b7, 8.16, there's a match, and b8, they don't match, but the values are all 0 because 4.79 times 10 to the minus 15 is 0. 8.47 times 10 to the minus 16 is 0. We can also generate the same output using this logarithm formula. We begin with the logarithm. So array formula, ln 1 plus x. That's the ln 1 plus x. And we factor in the ln 1 minus x, the 1 minus x, so ln 1 minus x, x. We just add another now that we have the portion, so we can factor in the 0.5. So it's 0.5 times ln. They're now on the same line. And their outputs are exactly the same because they're on the same line. And the coefficients, the regression coefficients, they're exactly the same. 0.804 B1, B0, B1, they match. B2, B3, they're exactly the same. 3.32. B4, B5, they exactly match. And B6, they're all 0. And B7, they all match. 8.16. And B8 are very small, so it's 0. Next, we factor in the Taylor-Maclaurin series sum of A tangent, which is equal to array formula, that is series sum of the x values. Now the x is raised from 2 to the n, so our n starts from 0 to infinity, so 2 times 0 plus 1, that's 1. The next will be 2 times 1 plus 1, 3, so 1, 3, 5, 7. So starting from 0, starting from 1, incremented by 2. So 1, 3, 5, 7, 9, and the coefficient will be this range. So now we can work on the coefficients. So this is equal to array formula, 1 over 2n, 1 over 2n plus 1, 2 times n plus 1 plus 1. The value of the goodness of the approximation of the Taylor-Maclaurin series sum is good only up between 0.3, negative zero point 0.3, and positive zero point 0.3. Beyond this value, there's already a difference. There's a difference already. There's a difference. The farther you go, there's already split ends. So there's the split ends here. So this is good only between 0.3 and negative zero point 0.3. They're accurate. That's how they accurate the approximation of the Taylor-Maclaurin series sum. That's because we're limited only from 0 to 8. But this is more accurate if we can go beyond 0 to 8 to infinity. Next, we calculate the regression coefficients, these values of B0, B1, B2, using LINEST. And because there's no degree of freedom, the rows and the columns are the same. So that we will start with the x to the 0 column, x to the 1 column, x squared column, x cubed column, x to the 4th until x to the 8th. So let's enter the power. So transpose of our values from 0 to 8. Now we can complete the 1 comma x matrix. So array formula of the x values raised to the power 0 to 8. Now that we have the 1 comma x matrix, we can now calculate the LINEST. So LINEST, since all these three columns are identical or same, we'll just use the Fisher. So LINEST, comma, that's r data y, then r data x will be this range. So our B0, 0, that's because 7.73 times 10 to the minus 17 is 0. So B1, 0.804, B3, 3.316, rounded was 3.32, our B5, negative 9.44, which is negative 9.43, and our B7, 8.16 is a match. Now we'll use LINEST on the expansion. So LINEST of the expansion, which is also an approximation to the Fisher and the inverse arctangent or inverse tangent. Um, so we have here this is wrong. So should be I. Now we're there. So the B0 is 0, negative 3.3.97 for B1. Our B3 is 0.798. It's a match. Our B5 is negative 1.4, and B7 is negative 1.7. These are these even values of 0. they are very small, 3.3 times 10 to the minus 18. And B2 is 5.37 times 10 to the minus 17, that's 0. Even B4, which is negative 2.11 times 10 to the minus 16, that's 0. And B6 is 2.9 times 10 to the minus 16, that's also 0. And B8 is also 0. So this completes the comparison of the Fisher inverse hyperbolic tangent and its logarithmic formula, and the Taylor-Maclaurin series sum of arctangent.